This video discusses about probability. Probability is the relative possibility that an event will occur, as expressed by the ratio of the number of actual occurrences to the total number of possible occurrences. So from this definition, we can find that the formula for probability is, let us represent probability P of T as the probability. And in order for us to get the probability of a certain event, we will get the number of actual occurrences, and we will represent it by NP, divided by the total number of possible occurrences, which we will be representing by N of S. Let's look at this simple example of probability. Supposing you'll be picking out a single card from a standard deck of 52 cards. What is the probability of picking a three of hearts, an ace, a diamond, and a face card? Let us begin with looking for the probability of getting a three of hearts. Note that we are getting a card from a standard deck of 52 cards. So what does this mean when you have a standard deck of 52 cards? This means a deck of 52 cards have it has four suits. We have the hearts, we have the diamond, we have the spade, and we have the clubs, right? And each of the suits has 13 cards each. In these 13 cards, we have the ace card, we have the cards 2 until 10, and we have the cards jack, queen, and king. This is also the same with all the other suits. So, how do we now find the probability of getting a three of hearts? What is the probability, or what is the number of times a three of hearts card occur? We only have one suit of hearts and one card of 3 with a heart suit on it. So we'll put here 1. And then what is the total number of possibilities? There are actually 52 cards that we can select on. So we will write in the denominator 52. Hence, the probability of getting a 3 of hearts is 1 out of 52, or 1 over 52. Let us now move to the next one, the probability of getting an ace. Looking at our diagram, there are actually 1, 2, 3, 4 aces with 4 different suits. So I will put here on the numerator, the total number of occurrences per ace is 4, and the total number of possibilities in the deck of cards is 52. We can further simplify this by dividing the fraction by 4, and we will get 1 over 30. Let us now go to the next one, the probability of a diamond. So looking at our diagram, there are actually 13 diamonds. So there can be 13 occurrences of diamonds. So I'll put that in the numerator. And the total number of cards is 52, or the total number of sample spaces. Again, we can divide this, we can simplify this by dividing it by 13, and we will get 1/4. That means the probability of getting a diamond is 1/4. Let's now go to the last, the probability of getting a face card. A face card would mean a card that has a face, like jack, queen, and king. So looking at our diagram, for each suit, we have three face cards. And since we have 4 suits, that means we have 12 face cards. Dividing that by 52, which is the total number of cards available, and then simplifying that by dividing by 4, we will get 3 over 13. Let's have another example. A committee of 4 persons is to be chosen from a group of 6 men and 7 women. What is the probability that the committee shall be made up of 2 men and 2 women? So let's have first and see if this kind of question is familiar with us. As you can see, this question is very similar to a combination problem. So let's first identify what is the combination here. In this problem, there are actually 6 men and 7 women. And from these 6 men, we need to choose 2 men, and from the 7 women, we need to choose 2 women. So this means that we need to get the combination of 6 taken 2 at a time and the combination of 7 taken 2 at a time in order for us to get the total number of occurrences for having a committee with 2 men and 2 women. So looking at our formula for probability, which is the probability of event is equal to NE over NS, our NE will now be the combination of 6 taken 2 times the combination of 7 taken 2, because this is the total number of occurrences for having 2 men and 2 women. Now, what is the total sample space? The total sample space would be the total number of men and women and the number of persons that you need to make up the committee. And if we have 6 and 7, that means we're getting the combination of 13 people taken 4 people at a time. Now let's try to solve the different combinations. So the combination of 6 taken 2, that means it's 6 factorial over 6 minus 2 factorial, 2 factorial, times 7 factorial over 7 minus 2 factorial, 2 factorial, all over 13 factorial over 13 minus 4 factorial, 4 factorial. Continuing our solution, we will have 6 factorial over 6 minus 2 factorial, which is 4 factorial, times 2 factorial. I would want to rename 6 factorial as 6 times 5 times 4 factorial, so that I can easily cancel 6 factorial and 4 factorial. I would also want to express 2 factorial as 2 times 1. Multiplying that to 7 factorial, which is 7 factorial divided by 7 minus 2 factorial, 2 factorial. Oh, sorry. 7 minus 2 factorial is simply 5 factorial. So I will just write here 5 factorial. And I want to rename again my 7 factorial as to 7 times 6 times 5 factorial, so that I can cancel 5 factorial and 5 factorial. Similarly, I would want to remove by 2 factorial and make it as 2 times 1. All over 13 factorial. So if I subtract 13 minus 4, that would give me 9 factorial, right? So I will just expand 13 until 9 factorial. And then I will have 9 factorial here, and then 4 times 3 times 2 times 1. I will cancel 9 factorial, and I will further simplify my equation or or this expression. So 6 divided by 2 is 3. 6 divided by 2 is 3. 4 times 3 is 12. 10 divided by 2 is 5. So what remains in my numerator is 3 times 5 times 7 times 3. And in my denominator, I have 13 times 11 times 5. So let's double check. So 3, 5, 7, and 3. And then we have 13, 11, and 5. So if we multiply that using our calculator, what will be our answer? So let's multiply. 3 times 5 times 7 times 3. That gives us 315. And 13 times 11 times 5 gives us 715. So if I divide both of them by 5, I will get, for me to express it in lowest terms, I will get 63 over 143. And this is the probability that a committee of 4 persons consisting of two men and 2 women can be chosen from a group of 6 men and 7 women. If you want to put it in percentage form, all you need to do is just divide the numerator by its denominator and then multiply the answer to 100. That means there is a 44% chance to get a committee composing of two women and 2 men. Let us recall the different properties of probability. Remember that the probability of a certain event is always between 0 and 1. That is, the probability of an event is greater than 0 or less than 1, but less than 1. The sum of the probabilities of all simple events is 1. That means the probability of event 1 plus the probability of event 2 plus the probability of all of its events is equal to 1. Again, this pertains to events of a certain situation. For example, rolling a die. What is the probability of getting a 1 when you roll a die? So the probability is 1 over 6. What's the probability of getting a 2 when you roll a die? Again, it's 1 over 6. So I'll write it here. Probability of getting a 1 in a die is 1 over 6. The probability of getting 2 in a die is 1 over 6. Similarly, the probability of getting a 3 is also 1 over 6. The probability of getting a 4 when you roll a die is 1 over 6. And the probability of 5 getting a 5 in a rolling a die is 1 over 6. And also for probability of 6, that's 1 over 6. If I add all of this, I will get 6 over 6, which is equal to 1. That's why the sum of the probabilities of all the simple events is 1. Also, the probability of an impossible event is 0. That means if a certain event cannot happen, then the probability is 0. But if you are sure that that event will happen, then the probability is 1. Let us now move on to the different laws or formulas that is related to probability. The first law is what we call the addition law. So in the addition law, it says here that if A and B are 2 events, then the probability that A or B or both occur is equal to the sum of the probability of their simultaneous occurrence. That is, P of A or B is equal to probability of A plus the probability of B minus the probability of A and B. Now, what is our clue here in order for us to use the addition law formula? For this one, let me tell you, we are looking for the probability of an or event. If A or B will happen. That means it's just either A or either B. It will not happen at the same time. Okay? So just the single probability of a certain event. So we're looking for or. And another clue that you need to remember is that the 2 events can happen at the same time. Okay? So again, we're looking for the probability of 2 events, one of the 2 events will happen, but the two events can happen at the same time. And if that is the case of the problem, then that means we need to apply the addition law. So the probability of A or B here signifies if A or B will happen. The probability of A is the probability that A will happen, and the probability of B is the probability that B will happen, and this probability of A and B is the simultaneous occurrence of A and B. One example of events that can happen at the same time is probability of getting a 3 or a hearts in a standard deck of 52 cards. So there is a card that is 3 and a heart at the same time. Okay, that is what we mean by simultaneous occurrence. So let's try applying this law using this example. On a TV quiz show, a contestant is asked to pick an integer at random from the first 100 consecutive positive integers. That is the integers 1 through 100. If the number picked is divisible by 12 or 9, the contestant will win a free trip to Cebu. The question is, what is the probability that the contestant will win the trip? So again, what are we looking for here? We are looking for the probability of getting a number that is divisible by 12 or 9. There is your clue, or. And look at the events. Is there a number between 1 through 100 that is both divisible by 12 and 9? Okay, so there is a number that is both divisible by 12 or 9. Therefore, this will be applying the addition law. So let's start first by listing the numbers from 1 to 100 that are divisible by 12 and divisible by 9. So first, for the numbers divisible by 12, we have 12, 24, 36, 48, 48, and then we have 60, 72, 84, 96. And for 9, we have 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, 99. Okay? So how many numbers are divisible by 12? We have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 numbers divisible by 12. How many numbers are divisible by 9? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if we apply for the formula, probability of A or B, the probability of A is 8 over 100. 100 is the total sample space because there are the numbers 1 through 100. The probability of getting a 9 is, getting a number divisible by 9 rather, is 11 over 100. Then you will subtract that to the probability of getting a number that is both divisible by 12 or 9. So let's encircle the numbers that are common to our answer. We have here 36. What else? We have 72 also. Do we still have more? None. Therefore, the numbers or the number of digits from 1 to 100 that are both divisible by 12 or 9 is 2. So we have 36 and 72. So I will write here 2 over 100. Simplifying this one, so 8 plus 11 is 19 minus 2, that is 17 over 100. So this is our answer. Another kind of probability are mutually exclusive events. What does this mean? When we say mutually exclusive events, the two events cannot happen at the same time. So two events cannot happen at the same time. That's why this kind of probability problem involves or does not have a minus p, a and b in the formula. But again, your clue here is you're looking for or, the possibility of an or event. Just one of it will happen. So your clue is there's an or, but the two events cannot happen at the same time. That is for mutually exclusive events. If the two events can happen at the same time and you are looking for or, then that is law of addition or the addition law. So the formula for mutually exclusive events is P of A or B is equal to P of A plus P of B. Let's try to apply that in this form, in this example. A box contains 3 red, 4 green, and 5 white balls. One ball is picked at random. What is the probability that it will be a red or white? So there's our clue. We're looking for red or white. So supposing I will represent red as A and white as B, then I am looking for the probability of A or B or the probability of red or white. And to do this, the formula is the probability of red plus the probability of white. And what is the probability of getting a red? There are actually 3 red balls out of 7 plus 5, 12 balls. There are 5 white balls out of the 12 balls. If we simplify this one, we will get 8 over 12. Simplifying further by dividing by 4, we will get 2 over 3. And this is the probability of getting a red or a white ball in a box containing 3 red, 4 green, and 5 white balls. If you want to put this in percent form, just divide 2 by 3 and then multiply the answer to 100%. The next is the law of complement. So what do we mean by law of complement? This says that the probability that an event A will not occur is equal to 1 minus the probability that it will occur. That's why the formula is P of not A is equal to 1 minus P of A. That means we are looking for the probability that it will not occur. Okay? So let's have an example. If the probability that the stock goes up is 0.6, what is the probability that it will not go up? So the clue word here is the word not, or probably something of the opposite. Like for example, the probability of becoming present, and then you're looking for the probability of getting absent. So those are opposite terms or opposite words that have opposite meanings. So in this problem, it says here that we are looking for the probability that it will not go up. And what is given is the probability that it will go up. That is 0.6. So it's 1 minus the probability that it will go up. And that is 1 minus 0.6. And our answer is 1 minus 0.6 is 0.4. So again, if you are looking for not or something opposite of what is the given information, then you will use the law of complement. Next is the law of conditional probability. In this probability, the conditional probability of an event A given the occurrence of an event B is defined by the formula P of A given B is equal to P of A and B over P of B, provided that P of B is not equal to 0. Remember that this portion should not be equal to 0 because if it becomes 0, then the answer will be undefined. So let's examine this one. So if A happens given B. B is always the condition. So it's like the premise, I will go if you will go. So if you will go is the condition, and the another event is I will go. So what is our clue word here? We're looking for an event that will happen given that a certain event happens. So there is this word given that, or suppose that, or if, or any similar terms that has the same meaning. Okay? So your clue here to think that it's conditional probability, there's a given that, there's a condition. And remember that B will always be the condition. So let's apply that in this example. Suppose a card is picked at random from a deck of cards. Given that the card is a black card, find the probability that it is a face card. So to answer this, let's first identify if we have that clue word for conditional probability. So I can see here, I'll encircle, there is this given that. So a certain event, A, will happen given that a certain event B happens. So based on this problem, which is our A, which is our B? So our A, or our B rather, is the black card. This is the condition. And what we are trying to find, given that a black card is picked, is a face card. So this means we are getting the probability of a face card given black card. And we are now looking for the probability of face and black over the probability of black. So this is just substituting A and B with face and black and black. So let us see. How many cards are there that are face and black at the same time? So analyzing again our standard deck of cards, we have two suits that are black, the spades and the clubs. And each suit has 3 face cards. So that means there are 6 face and black cards out of 52 cards. Over, how many black cards do we have? 2 suits are black, therefore 13 plus 13 is 26 out of 52. Dividing this one means 52 and 52 will cancel, and what remains is 6 over 26. Dividing this by 2, to simplify, we will get 3 out of 13. And this is now our answer. That means the probability of getting a face card, given that it is a black card, is 3 out of 13. We also have what we call the general multiplication law. This states that if A and B are 2 events, then the probability of A and B is given by the formula. Probability of A and B is equal to probability of B times the probability of A given B. This law is actually a derivation of the conditional law, or the conditional probability law. As you can see, all the terms in the formula are similar with the one on conditional probability. However, what we're looking for here is end. We're looking for end, and there is a condition given that. So this means if you analyze a problem and you're looking for end, and then the situation has a condition, then you will use the general multiplication law. Let's try to practice on this example. The probability that the stock market goes up on Monday is 0.6. Given that the probability that it goes up on Monday and goes up on Tuesday is 0.3, find the probability that the market goes up on both days. So first, let us identify if we have the keywords. We have this given that as a keyword, and then Both also signifies end. And we are looking for the probability that it goes up on both days, on Monday and Tuesday. So, let's identify what is the condition. Which of the day is the condition? Is it Monday or Tuesday? That's right. The condition is Monday. So this is our B. This is our A. So let us now apply it in the formula. The probability of Monday and Tuesday, that it goes up on Monday and Tuesday, is equal to the probability of B. So this is the probability of Monday times the probability of A given B. The probability of probability of Tuesday given it goes up on Monday. Okay, so the probability of Monday is 0.6, and the probability that it goes up on Tuesday, given that Monday went up, is 0.3. Therefore, the answer is 0.18 or 18%. That is the chance of the stock market goes up on both days. So again, our clue here is you're looking for the end, you're solving for end or for both events to happen given a certain condition. The general multiplication will be used. And last, we have the independent events. This means that two events, A and B, are said to be independent events if the probability of the simultaneous occurrence of A and B is equal to the product of the respective probabilities. That is, P of A and B is equal to P of A times P of B. When we say independent events, even if the events happen at the same time, they do not affect each other. Like for example, if I toss a coin and I roll a dice at the same time, their probabilities will not affect each other. So that is what we call independent events. And the clue word here is just and, or both. So both will happen at the same time, but they do not affect each other. So let's try to practice on this example. A number is picked at random from the digits 1, 2, 3, and 9 until 9, and a coin and a die are tossed. Find the probability of picking an odd digit, getting a head on the coin, and getting a multiple of 3 on the die. So let's identify first what are the different events here. We have the number to be picked at random. We also have a coin being tossed and a die being rolled. So these are the three events that will simultaneously happen. So looking at these events, will the number picking from digits from the digits 1, 2, 3 until 9 affect the possibility of getting a head or a tail on a coin, or getting a 1, 2, 3, 4, 5, 6 on a die when tossed? Of course not. They are independent events. They do not affect each other. Therefore, let us name which is A, which is B, which is C. So let's say A is the number picked, B is the coin being tossed, and C is the die being rolled. So we are getting the probability of getting an odd digit, the probability of getting a head on the coin, and the probability of getting a multiple of 3 in a die. So from the numbers 1, 2, 3 until 9, how many are odd numbers? So we have 1, 3, 5, 7, and 9. So we have 5. What is the total number of digits available? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 digits. So the probability of getting an odd digit from the numbers 1 to 9 is 5 over 9. How about for the coin? The probability of getting a head. There's only one head in a coin, and there are two events, the head and the tail. And for the multiple of 3 on the die, so we only have 3 and 6 there. So that's 2 out of 6. To get the probability of getting an odd and a head and a multiple of 3, that's equal to 5 over 9 times 1 over 2 times 2 over 6. And that would give us, if we simplify, so we can cancel 2 and 2 here. So we will just have 5 out of 54. So 5 out of 54 chance, or if you want to put it in percentage, it's 9.2% in order for you to get all of these events simultaneously. I hope you understood probability and the different laws concerning probability.